Okay, today we're going to recap day 7 and start on day 8. So if you will go to page 30 in your packets, you'll see you have all this empty space. We're going to do some quick review from yesterday because I know there were many people absent. Yesterday we talked about scale factor, we talked about ratio of areas, and we talked about ratio of volume. And we talked about how they all related. So there was a special relationship that if you knew the scale factor is like length of a side, a height, a radius. It's the length of something, okay? Something that you can measure with a ruler, basically. So if I know the scale factor, in order to figure out the area ratio, I raise that scale factor to the second power. Remember, area is always in units squared, like square feet, square inches, square meters, those kind of things. So that's how you can remember area is squared. Volume, you take whatever your scale factor is and you raise it to the third power, or you cube it. Okay, remember, volume is always in like cubed inches, cubed feet, those kind of things. Okay, this is because that areas are two-dimensional, right? They're 2D. There's like a length and a width. We're coloring in a surface, okay? Volumes are 3D. They're solid shapes, right? They have 3 dimensions. Those are other ways you can kind of remember these things. Okay, so here are some examples. If you start out with this scale factor of 3 to 4, and you want to know the area ratio or the volume ratio, area ratio, you would have to square both parts. So our area ratio would become 9 to 16. Volume ratio, you would have to raise each part to the third power. So on your calculators, squaring is super easy because there is a button for squaring. It's right here. So 3 squared is 9. Okay, 4 squared is 16. Cubing, you can do 2 ways. Okay, if I did 3 to the third power, one way to do that is to type in 3. This button is for exponents. To the third and equals, and we get 27. Okay, so 4 to the third is 64. Another way to do it, if you look above the 1 key, there's an x to the third power. So if I hit 4 and I want to raise it to the third, since it's in green, I can hit the green button and then 1, and it raises it to the third power. Okay, so super easy working forwards. Yesterday we did a few where we had to work backwards. So let's say that we started with an area ratio, and our area ratio was 4 to 25. Okay, sorry, I made a mistake and was writing 4 to 25. Since these are already squared, okay, this is like saying this is x squared over y squared. If I want to work backwards, I have to unsquare it. To unsquare something, you're taking the square root. Square and square root are opposites of each other. Opposites are next to each other on the calculator here. Divide and multiply are opposites, add and subtract are opposites. Okay, so square and square roots are opposites. So in order to work backwards, I have to use my square root key. So I would take the square root of 4 and the square root of 25 to get my answer. Okay, so square root of 4 is 2, square root of 25 is 5. That's how I would work backwards for area. Okay, if I was given volume and had to work backwards, so let's say I had 1 to 8. Okay, and if I have to go backwards to scale factor, this is x cubed over y cubed. To take a cubed root, if you look on your calculator above the 0, there's a cubed root button. Okay, cube is here, cubed root is there. If it's in green, you have to use the green button to get there. Okay, so you're using the cubed root button to work backwards. When I take the cubed root of 1 on my calculator, and the cubed root of 8, I'm going to get 1 over 2. Okay, so if you want to watch how I type in 8, I hit the green button, I hit the 0 button, it gives me 2. Okay, if I type in 1, hit the green button, hit the 0 button, it gives me 1. Okay, so that's a review of what we did yesterday for day 7. Okay, now we're going to look at day 8 because day 8 is using this stuff to solve other problems. Okay, so day 8, we have a few examples we're going to do. It says a square tile is 3 inches on each side. So a square tile would look like this. Another square tile is 12 inches on each side. So it's slightly bigger, 12 inches on each side. How many smaller tiles would have the same area as one larger tile? So we can do this a few different ways. Okay, we could draw a picture, right? If I had 3 going across here and 3 going, oops, I did not divide that very well. Let's do it like this. Okay, 4 would fit this way, 4 would fit this way, so that's going to give me a total of 16. If I did my ratios, I have scale factor is 3 to 12 because I'm comparing the length to sides. We want to simplify that. So remember in your calculators, if you type in the fraction 3 over 12 and you hit the equals button, it'll simplify that for you. Okay, this is talking about area. So we want to know what is our area ratio. So if I move to area, I have to take my scale factor and I have to square it. So 1 squared over 4 squared is 1 to 16. Okay, I get the same thing as if I would have drawn the picture. Okay, so it's 16 tiles would have fit in one larger one. All right, number 2. A rectangle has a length of 8 and a width of 5. So if we draw a picture to help us see what's going on, we have 8 and 5. If the sides of the rectangle are tripled in length, what is the new area of the larger rectangle? So if I were to triple it, this would become 24 and this would become 15. So my scale factor, I can match up the sides that match up and I simplify that, right? I tripled it, so it's 1 to 3. I want to know what is the new area of the larger rectangle. So I can do this 2 ways. Okay, I could calculate the area and do 15 times 24, and that gives me 360. Or I could use my area ratio. Okay, my area ratio tells me it's 1 to 9. So whatever this one was, I'd have to multiply it by 9. Okay, either way, I get the same answer. 2 rectangular prisms are similar. The volume of the smaller prism is 24. The ratio of the corresponding widths is 1 to 5. So this is telling me my scale factor is 1 to 5. My volume ratio would have to be 1 cubed to 5 cubed, which is 1 to 125. Okay, this is where we're going to have to use a proportion. So if I know my volume ratio is 1 to 125, this is smaller over bigger. The smaller prism is 24. The larger one is x. I don't know it, right? I want to know the volume of the larger. So I'm going to cross multiply. 1 times x and 125 times 4. So x is 500. So my new volume of the bigger one is 500 inches cubed. Okay, example 4, we have two rectangular pyramids that are similar. The total surface area of the smaller pyramid is 30 feet squared. The ratio of the corresponding edges is 1 to 3. So that's telling me my scale factor is 1 to 3. We're doing area, so I know I want to change this to 1 squared over 3 squared, which is 1 to 9. I'm going to use this to make my proportion. I know that the smaller pyramid is 30. Smaller goes on top. I don't know the bigger one, so it goes on the bottom. I cross multiply. 1 times x is x. 9 times 30 is 270. So our unit of measure is feet, so feet squared. Okay, I'm going to stop the video here, and I'll do another video for the practice.